All right, here we go. Our compacted math SparkNotes day 2. So today we're going to be talking about Unit 3 and Unit 4. So Unit 3 was all about division. And yes, we covered a lot of stuff in this unit. We talked about our divisibility rules. How do we divide whole numbers? What does it look like when we start having decimals? What do the models look like? And then RIP remainders. We murdered them, they're gone. So we're going to start with the divisibility rules. So I have two problems here for us, and I want us to circle the numbers that 48 is divisible by. Well, every single number that we have is always going to be divisible by 1. That should be easy peasy lemon squeezy. Now, our rule for divisible by 2 is if the number is an even number. 48 is an even number, so it's divisible by 2. 3, the divisibility rule, is if the sum of its digits, so 4 plus 8 would give me 12. If that is divisible by 3, then 48 is divisible by 3. So again, 4 plus 8 gives me 12. 12 is divisible by 3, so that means 48 is divisible by 3. Our divisibility rule for 4 is if the last 2 digits, well, in this case, there are only 2 digits, is divisible by 4. So I know that 4 can go into 4, 4 can go into 8, so 48 is also divisible by 4. 5 would be if the last digit is a 5 or a 0. Well, I have an 8 here. That's not a 5 or a 0, so it's not going to be divisible by 5. 6 is if the number is divisible by 2 and 3. Well, we already know it is, so it's divisible by 6. 9 is if the sum of its digits is divisible by 9. So again, we said 4 plus 8 gives us 12, but 12 is not divisible by 9, so 48 is not divisible by 9. And then last 10 is if the last digit is a 0. Well, we have an 8 here. That's not a 0, so it's not divisible by 10. So here we go. 90, it's divisible by 1. It's divisible by 2 because it's an even number. It's divisible by 3 because 9 plus 0 is 9, and 9 is divisible by 3. 4. So if I do some work here, I'm going to be honest, 4 is always the one that I struggle with, especially when it's 2 digits. So I'm just going to come over here, solve it to the side. There's no shame in that. So 4 goes into 9 2 times. Subtract and I get 8. Oop. We're through here in the wrong place. But I know that 4 won't go into 10 evenly, so I'm going to end up with a remainder. So therefore, 90 is not divisible by 4. It's divisible by 5 because it ends in a 0. It's divisible by 6 because it is divisible by 2 and 3. It's divisible by 9 because 9 plus 0 is 9, and divided by 9 can be done. And then it is divisible by 10 because it ends in a 0. Now, for this next part here, we're just going to label the different parts of our division problem. So this is, again, our division house. What goes on the inside is called the dividend. The number on the outside is called the divisor. And the one having the party on the roof is called our quotient. The quotient is also the answer to our division problem. So here we go. Our very first problem, and I'm going to zoom in, so sorry for my pterodactyl. It says 280 divided by 14. So I have 14. I know 14 can't go into 2, but 14 can go into 28 a total of 2 times. So 2 times 14 gives me 28. When I subtract, I get 0, but I still have to bring down this 0 here. Well, 14 goes into 0 0 times. So I know that my final answer here is 20. Our next problem is 7/10, it's 84 divided by 7/10. Now, when I have a decimal in my divisor, I can't divide by a decimal. So this is where we sing our song that goes, move it over, bring it up, and divide. So I'm just going to move that decimal so it looks like this becomes a whole number. But if I move it one place in the divisor, I also have to move it one place in the dividend. I'm going to add a 0 as a placeholder. Bring that decimal up to the top. And now my problem looks like 840 divided by 7. So I have 7 goes into 84. Excuse me. A total of 12 times. 12 times 7 gives me exactly 84. I subtract and I get 0, but again, I have to bring down that 0. 7 goes into 0 0 times, so I get a final answer of 120. Now, for our next one, 35 hundredths divided by 5. Now, this time I only have a decimal in the dividend, which is okay. I can have it there. There's no decimal on the divisor, so I don't have to move anything over, but decimals like to have their parties on the roof, so I'm going to go ahead and help it, ooh it, raise the roof. Bring it straight on up to the top. So 5 can't go into 3, so I have to put a 0 there. But 5 goes into 35 a total of 7 times. 7 times 5 is 35. So when I subtract, I get 0. Now our next one, I have 2 and 8/10 divided by 4/10. I've got a decimal in the divisor, so I have to move it over, bring it up, and divide. So now it looks like 28 divided by 4. Well, 4 goes into 28 a total of 7 times. So I get a final answer of 7. Now, for our next few problems, I didn't go ahead and set them up with the correct number in the house. What we have to remember when we see a problem like this is that the first number always goes in the house. It's not the bigger number, it's just whatever number comes first. So 14 divided by 2/10, since 14 comes first, 14 is going to go in the house. I'm going to go ahead and get rid of that unnecessary 0. I don't need it. I've got a decimal in my divisor, so I have to move it over, bring it up, and divide. So 2 will go into 14 7 times. 2 times 7 is exactly 14. Bring down the 0. 2 goes into 0 0 times. So sure enough, I get a final answer of 70. Our next one is 5/10 divided by 10. Again, 5/10 comes first, so I'm going to put that inside of the house, getting rid of that unnecessary 0. I don't need it there. Now, there's no decimal in the divisor, just in the dividend, so all it's going to do is ooh it, raise the roof. 10 cannot go into 5, so I'm going to put a 0 up at the top. I'm going to add a 0 so I can keep dividing. But 10 will go into 50 a total of 5 times. I have a remainder of 0, so I get and 5 hundredths. For our next one, I have 30 and 60 hundredths, which I'm going to change to 30 and 60, or excuse me, and 6/10 divided by 15. No decimal in the divisor, just in the dividend, so ooh it, raise the roof. 15 will go into 30 2 times, but I have to bring down the 6. Now, 15 cannot go into 6, so I have to put a 0 up here at the top, but I don't want this remainder left. So I'm going to add a 0, bring it on down. So 15 will go into 64 times. So I get a final answer of 2 and 4 hundredths. And our last problem, I have 7 and 2/10 divided by 9/10. I do have a decimal in the divisor, so I need to move it over, bring it up, and divide. 9 will go into 72 8 times. So I get a final answer of 8. All right, with our division, we need to move on to our different division models. So we're going to start with division quick picks. Now, remember, when we look at these quick picks, anytime I see this big square right here, that represents 100. Each of these lines represents 10. Each of these dots represents 1. So what I like to do on these problems is I go ahead and label everything that I see. So I labeled my block as 100. I see 1, 2, 3 lines, so that would give me 30. I see 1, 2, 3 lines, so that would give me 30. And 9 dots, so I have put a 9. So I'm going to set up my problem over here, and I know that this is inside the house, and I'm going to add all of this together. So 100 plus 30 plus 30 plus 9 would give me 169. Then to get my divisor and my quotient, I'm going to count the groups of 10 that I see in these problems. So I know that there are 10 10s inside of 100. So that would be 10, 1, 2, 3, which would give me 13. I'm going to do the same thing for my quotient. So I know that there are 10 10s in here. 1, 2, 3 would give me 13. So this problem is showing that 169 divided by 13 would give me 13. Our next one, I'm going to do the same thing. I'm going to start off by labeling it. So this is 100, this is 20, this is 30, and this is 6. So all together, 100 plus 20 plus 30 plus 6 gives me 156. I'm going to count my tens. So there are 10, 1, 2 for a total of 12. There are 10, 1, 2, 3 for a total of 13. So this is 156 divided by 12 gives me 13. Now, for my division models, these are going to work a little bit differently, okay? When I have a whole number, for my divisor, that second number, this is like I'm creating groups. Now remember, in a division problem, the total always goes first. So what this is saying is I have 10 objects that I need to separate into 5 groups. So what I'm going to do is I'm going to go ahead and draw 5 circles for my 5 groups. So there's 1, 2, 3, 4, 5. Now, I kind of treat the total, and I don't just go put all 10 in one. I kind of split them up, and I go back and forth between each of the groups to make sure they all get filled evenly. So I need to split up 10. So I'm going to put 1 in the first group, 2, 3, 4, 5. I'm going to go back to that first group for 6, 7, 8, 9, 10. So this right here shows that in each group, they're going to have 2 objects. So 5 divided by 10 would equal 2. For our next one, again, I have a total of 2 6/10 that I'm dividing into 2 groups. So I'm going to set up my circles. So there's 1, there's 2. And when you have decimals, I take it one place value at a time. So I'm going to start with the ones. So I have 2 ones that I need to break up into 2 groups. Well, that's easy enough. Each one gets 1. Then there are 6/10 to be separated between 2 groups. So I'm going to go back and forth. So this will be 1, 2, 3, 4, 5, 6. So that gives me in each group, I have 1 whole and 3/10. Oops, sorry, I didn't realize I was off the screen. All right, for our next one, I have 1 4/10 divided by 2. Now this one looks a little bit differently. So what I need to do here is I need to shade in whatever the first amount is. So I'm going to shade in, it's going to be really ugly shading, 1 whole and 4/10. And then what I'm going to do is I'm going to separate this into 2 groups. Now, I know that this looks like 14, and 14 divided by 2 would give me 7. So I know that there are going to be 7/10 in each of these groups. So I'm going to count out 1, 2, 3, 4, 5, 6, 7. I'm going to include those 7/10 in one circle, and I'm going to include the other 7/10 in the second circle. For this one, again, I'm going to shade in 1 5/10. Again, sorry for my ugly shading. So there's 1 whole, there's 5/10. And again, I know this looks like 15, and 15 divided by 3 would give me 5. So I'm going to make sure that I have 5/10 in each of these groups. So there's 1, 2, 3. Oh, I didn't write this. So in each group, there would be 5/10. All right, then the last thing we did is we officially killed remainders, right? We don't normally like to write our answers with remainders, but sometimes in word problems, remainders can actually end up being our answer, or they can help us get the correct answer. So we have to pay attention to when remainders are needed and when they're not. So our very first problem says, Mrs. Malish has 980 stamps in her collection. She puts the stamps into display cases. Each display case contains 30 stamps. So this is important. 980 stamps, each case contains 30. So I need to know how many display cases will Mrs. Malish need for her stamp collection. So she's going to take those 980 stamps and she's going to break them up into groups of 30. So here we go. 30 will go into 98 3 times. 3 times 30 is exactly 90. And when I subtract, I get 8, bring down the 0 to make it 80. Now 30 will go into 80 only 2 times. So that's only 60. And when I subtract, I get 20 as a remainder. So that means if she only bought 32 cases, 20 stamps would be left out of the case, which can't happen. So instead of buying 32 cases, this remainder tells me, hey, she needs to buy an extra case to fit those 30 or to fit those 20 extra stamps. So Mrs. Malish actually needs to buy 33 cases. That'll give her enough to keep all of her stamps. But then in our next problem, where it says Luke has 158 dog treats at home, and he wants to divide them evenly among 8 boxes. So how many dog treats will Luke have left over? That is important. I don't care how many groups or how many boxes he's going to make or what's going to go in each. I want to know how many dog treats will not fit in those 8 boxes. So we're going to take 158 dog treats. We're going to break them up into 8 boxes. So 8 will go into 15 just one time. When I subtract, I get 7. Bring down the 8. Now I know that 8 times 9 will give me 72. So it looks like there are going to be 19 dog treats in each box, but there are going to be 6 treats left over. 6 treats that just won't fit in that box. All right, and Unit 4 was all about factors and multiples, prime versus composite, prime factorization, and our greatest common factor and least common multiple Venn diagram. So let's start off with factors and multiples. So when we talk about a number having factors, factors are just numbers that are multiplied together to create a larger number. So if I wanted to list all the factors of 120, I need to think about all the ways that I can multiply and end up with the number 120. So I like to write my factors in pairs. So I'll always start with, I know that I can do 1 times whatever the number is, so 1 times 120. I know that 120 is an even number, which means 2 is a factor. So that would be 2 times 60. I know that 1 plus 2 gives me 3, so 3 is going to be a factor. So it's going to be 3 and 40. I know that 4 is going to be a factor because the last 2 digits are 20, and 20 is divisible by 4. So our factors here are 4 and 30. I know it's divisible by 5 because it ends in a 0. So this is going to be 5 and 25. I know that 6 is an option because it's divisible by 2 and 3. So this is going to be 6 and 20. 7 is not an option. And I do believe 8 is an option. Yes, 8 is going to be an option. It's going to be 8, and let me do some math here really quick. It's going to go in one time. It's 8 and 15. 9 is not going to be an option, but 10 and 12 are going to be an option. So those are all of our factors of 120, all the ways we multiply and get that number. Now, multiples can be found by skip counting. So if I wanted to list the first 10 multiples of the number 8, well, if I skip count by 8, so I would have 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. Those are the first 10 multiples of 8. All right, then moving on. So I know that prime numbers have exactly 2 factors. That would be 1 and itself. Composite numbers are going to have more than 2 factors. Now, it's important to remember that both prime and composite numbers have to be greater than 1. So 1 is not an option here. So I'm going to circle all the prime numbers in the chart. And I like to sing the beginning of our chicken dance song that goes 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Now, I always know that we have a little bit of issues with that second verse, but we have 31, 37, 41, 43. Ooh, yeah, that's right. And then we have 47, and that ends it for the first 50, because then we would start going into the rest. So there are all of our prime numbers. So when we look at this, it's important to note that 4 is never an option, 6 is never an option, 8 is never an option, our 10s are never an option. The only even number that is a prime number is going to be that number 2. Everything else is going to be an odd number. And this is important because then when we get into prime factorization, we're kind of combining the 2 things together. So remember, those factors are our numbers that we multiply together, but I'm trying to get down to all of the prime ones. So we're going to build our factor trees. So I just need 2 numbers that multiply together to give me 144. It's going to be the numbers 12 and 12. But 12 is not a prime number. I can break it down even further. One way I can break it down would be 6 and 2. 2 is a prime number, so I circle it, but 6 is not. And I can break 6 down into 3 and 4. 3 is a prime number, so I circle it, but 4 is not. So I break it down into 2 and 2, both of which are prime. Oh, hello. I was doing something else. Go back. 6 and 6 would be 3 and 2, and I'm done. Why am I trying to create more work for myself? I'm done. Okay, let's reverse. Here's where my brain was thinking. My brain was thinking I could also break down 12 into the numbers 3 and 4. 3 is a prime number, but I need to break down 4 into 2 and 2. Goodness, this is why I should never make these videos after school. So now that I have all prime numbers, I'm going to write the prime factorization. And remember, I always want to put them in order from least to greatest. So I see that I have 1, 2, 3, 4 2's. So that would be 2 to the power of 4 times 1, 2, 3. So 3 to the power of 2. Okay, our next one, the number 75, I can break it down into 3 and 25. 3 is a prime number, so I circle it. 25 can be broken down into 5 and 5, which are both prime numbers, so I'm done there. Putting them in order from least to greatest, I only have 1 3, but I have 2 5s, so that would be 5 to the power of 2. And then our last one, 38, can be broken down into 3 and 19, both of which are prime numbers. I love those problems, so it's just 3 times 19. The reason we need to know about all of this prime factorization, all of our prime numbers, all of our factors, is because when we start doing greatest common factor and least common multiple, all of this helps us figure out those two things. So let's say I wanted to find the greatest common factor and the least common multiple of the numbers 12 and 30. What I need to do is I first need to break these down into only their prime numbers. So I'm going to start with 12, and I'm not going to mess it up this time. I have 6 and 2. Circle 2, break down 6 into 3 and 2. Now, this time, I don't want to use exponents to write this out. So I'm just going to write this as 2 times 2 times 3. Then I have 30, which I can break down into 3 and 10. 3 is a prime number. 10 can get broken down into 5 and 2, which are both prime numbers. So this will be 2 times 3 times 5. Now, in this Venn diagram, I'm just going to make the left side 12, the right side 30. I'm going to look at these two prime factorizations, and any factors that they have in common, I'm going to write in the middle. So I see that they both have 2 in common. So I have 2 and 2, so 1, 2 goes in the middle. They also have a 3 in common. But then 12 has another 2 that's just by itself, and 30 has a 5 that's just by itself. So to find the greatest common factor, I'm looking here in the middle. So I have 2 times 3, which would give me a greatest common factor of 6. Then for my least common multiple, I'm going to take whatever on the left, which would be 2, whatever my greatest common factor is, which is 6, and then whatever on the right, which is 5. Now, since I'm multiplying, it doesn't matter what order I multiply in, so I like to make this as easy as possible. So I see that 2 times 5 would give me 10, times 6 would give me 60. So 12 and 30 have a greatest common factor of 6 and a least common multiple of 60. Let's do one more. 72 and 90. So I know 72 is 9 and 8, both of which are composite numbers. So 9 can get broken down into 3 and 3. 8 can get broken down into 4 and 2. 4 is composite, and it can get broken down into 2 and 2. So this would be 2 times 2 times 2 times 3 times 3. 90 can get broken down into 9 and 10. Both are composite. So 9 is 3 and 3. 10 is 5 and 2. So this would be 2 times 3 times 3 times 5. So again, I'm just going to make 72 the left, 90 the right. So I see that they have a 2 in common. They have a 3 in common, and they have another 3 in common. And then 72 has 2 2's left over to itself. 90 gets a 5. So for my greatest common factor, that would be 2 times 3 times 3. Well, 3 times 3 is 9 times 2, which would be 18. For the least common multiple, 2 times 2 would give me 4, times my greatest common factor, 18, times the right, which would be 5. So again, I'm going to make this as easy. Oh, sorry, I didn't realize y'all can see. I'm going to make this as easy as possible as I can. I know that 4 times 5 would give me 20. 18 times 2 is 36, so add a 0 and we get 360.